Have you ever stopped to think about the hidden patterns in the things we buy? I mean, these seemingly random items that, when you really dig into the data, are actually deeply connected. Well, today, we're going to pull back the curtain on the science of finding those secret relationships. And it all kicks off with this classic, almost mythical story from the world of data mining. The legend goes that a big retail chain discovered that on Friday nights, men who were buying diapers also had this strange tendency to buy beer.
I mean, it sounds totally random, right? A coincidence, at best. So how on earth could a business not only spot a pattern like that, but actually be confident enough to act on it? You know, maybe even rearranging the whole store to put the beer aisle closer to the baby supplies.
Well, this is the exact puzzle we're going to solve today. Because, spoiler alert, it's not a lucky guess. It is a really powerful data technique at work. And understanding it reveals this hidden logic that shapes, well, everything from how a store is laid out to the ads you see online.
The answer, of course, isn't magic. It's a super systematic method. Think about it. Businesses are collecting millions, even billions of transactions. And hidden inside that absolute mountain of data are these incredibly valuable insights, just waiting to be uncovered.
All right, so let's give this thing a name. What is this technique actually called? This whole method of finding out what goes with what? It's one of the most fundamental concepts in data science. So let's break down how it actually works.
Officially, it's called association rule mining, but you'll more often hear it called something more intuitive, like market basket analysis. And the goal is really simple. It's all about finding if-then rules. You know, if a customer buys X, how likely are they to also buy Y? It's all about finding items that can help predict the purchase of other items.
Now, here's what's really cool about this. This is a form of unsupervised learning. And what that means is we don't tell the computer what to look for. We're not saying, hey, go check if diapers and beer are related. We just feed it all the raw transaction data, and the algorithm discovers these connections all by itself. It's pure, unguided discovery. But, okay, in a store with thousands of products, how does an algorithm possibly know which patterns are meaningful and which ones are just random noise? Well, it all comes down to two really crucial measurements. Let's use a super simple example to get our heads around this. Here we have 5 customer transactions from a grocery store. We're going to use this tiny little data set to really understand the 2 key metrics that power this entire analysis. So first up is a metric called support, and this is super straightforward. It just measures how frequently a set of items appears together in all transactions. So if we look at our table, the combo of diapers and beer pops up in transactions 2, 4, and 5. That's 3 times out of 5 total transactions. So the support is just 3 divided by 5, which is 60%. It simply tells us how popular that combination is overall. All right, the second metric is confidence. And this is where that if-then idea really gets its power. Confidence measures reliability. So for our rule, if you buy diapers, then you buy beer. We only look at the transactions that have diapers in them. That's a key difference. In our example, that's transactions 2, 3, 4, and 5. Okay, so now, out of just those 4 baskets, how many also have beer? Well, we see beer in transactions 2, 4, and 5. That's 3 of them. So the confidence is 3 divided by 4, or 75%. So let's nail this down, because it's the crucial point. Support tells you how common a combo is across everybody, across the entire data set. But confidence zooms in and tells you how likely someone is to buy beer, given that you already know they bought diapers. They measure 2 very different but equally important things. And this brings us to the absolute key insight. A rule needs both. Imagine a rule like, if a customer buys an ultra-rare collectible, they also buy its protective case. That rule might have 100% confidence, but if only one person bought that collectible all year, the rule isn't very useful, is it? A truly strong, actionable rule needs to happen often, that's high support, and it needs to be reliable, that's high confidence. Okay, so we get it. We know how to measure a rule's strength. But in a real store with thousands of products, the number of possible combinations is astronomical. How can we possibly find the good rules without taking, centuries to compute?
Yeah, if you tried to brute force it, checking every single pair, every trio, every combo of 4 items, the calculations would just explode. It would become impossible, even for the most powerful supercomputers. We need a much, much smarter way to do this.
And that smarter way is this really elegant algorithm called a priori. It boils the problem down into 2 simple steps.
First, it efficiently finds all the groups of items that appear frequently enough to even be interesting, the ones that meet some minimum support level we set. Then, and only then, does it bother to check those frequent groups to see if they can form rules that meet our minimum confidence level.
The absolute genius of the a priori algorithm is how it saves time. It works from the bottom up. It has this clever property. It knows that if, say, the single item anchovies isn't popular enough to meet our threshold, well then any larger combination that includes anchovies, like anchovies pineapple pizza, is also guaranteed to be unpopular. By pruning these dead ends early, it avoids wasting tons of time and can efficiently search through massive datasets.
And while this whole thing started with grocery stores, this idea of finding associations has applications that go way, way beyond the retail aisle. In fact, you probably interact with it every single day without even realizing it.
You know when Netflix suggests a new show because people who watched X also watched Y? That's association analysis. In healthcare, doctors use it to find symptoms that commonly appear together, which can point to a specific diagnosis. And in finance, it helps detect fraud by flagging weird combinations of transactions that just don't fit normal patterns.
So from really high-stakes predictions, like that famous story of Target figuring out a shopper was pregnant just based on changes in her purchasing habits, all the way down to the simple decision of why the milk is always at the back of the store, these hidden rules are constantly shaping our world and our choices.
So there you have it. We've cracked the mystery of the diapers and the beer. It's not just some silly urban legend. It's actually a perfect example of how data can reveal the surprising and sometimes weird logic behind how we all behave. So, if you're going to remember just a few things, remember these. 1. This is all about finding simple if-then patterns in our data. 2. A strong rule needs to have both high support, meaning it happens a lot, and high confidence, meaning it's reliable. And 3, none of this would be possible on a massive scale without clever algorithms like a priori doing all that heavy lifting for us.
And that kind of leaves us with a final thought to chew on. The next time you're shopping or just scrolling through recommendations on your phone, take a second and wonder, what hidden patterns, what unseen association rules are quietly guiding your decisions? The connections are absolutely everywhere once you know how to look for them.